The sine law or the sine rule is the sine law or the sine rule. The sine law or the sine rule is a rule that we can use to do some calculations with non-right angle triangles. So if you don't have a right angle triangle, you can't use SOHCAHTOA. You can rely on the sine rule. Now, one thing I'd like to point out again is the naming convention of these sides, where we use a capital letter for the angle, and then we use the corresponding lowercase letter for the opposite side. And this helps us make sure we're putting the correct values in the formula in the right place. So the formula is a ratio, and it's saying that the side of angle A over A is equal to the sine of angle B over B, which is also equal to sine C over C. In practical terms, we would never use an equation with three different things in it. We only would choose two, and so we need an angle and a side pairs, two pairs, to use this formula correctly. Another thing I'd point out is that you can also use this formula inversely. And so it's just as correct to say that A over sine A is equal to B over sine B, which is equal to C over sine C. And depending on the information I have, determines which one of these ratios I'm going to use and the way I'm going to write it. However, you can use either one. As long as you follow the correct algebra rules, you'll still be correct. Now let's look at a few examples and see how we can apply this sine law to solve for angles and sides. In this example here, we see we have two pairs of opposite sides and angles. So in one case, we have the x is paired up with the 38, and the 54 is paired up with the 3.7. And so this is a situation where you know you're going to be using sine law. And the x is a side length, and that's the unknown. And so what I would do is put that in the numerator of my equation. That's just the way I like to do it. I find it easier to solve that way. You can have it in the denominator. There's just a couple extra steps algebraically, but I leave it in the numerator. And so the equation I would end up writing would be x over sine of 38 would be equal to 3.7 over sine 54. And to isolate x, I have the sine 38 in the denominator, so I'm going to multiply both sides by sine 38, and that would leave me with x equal to 3.7 times sine of 38, all divided by sine of 54. And now I would plug this into the calculator, and I can get my result for x. And I end up with a value of 2.8 centimeters. So pause the video and try this question on the right on your own, and then compare your answer to the one that I'm going to post in a second. Hopefully you got 18.7 centimeters. You see that I identified the pairs as the x and the 93 degrees and 42 degrees and 12.5. Moving on to the next set of examples, we're looking at a situation where we're trying to find the angle. And so this is slightly different than what we just did. But here, again, we have to identify, are there angle side pairs that go together? And here we have the x and the 3.4 and the 75 and the 5.6 going together. And now this time the x is the variable as the angle. And so I'm going to write the equation the way that it's originally written up top. So I would write this as sine x over 3.4 is equal to the sine of 75 over 5.6. And again, the only reason I'm doing that is just because I like to have my unknown variable in the numerator. I find it easier to work with algebraically. And so I have a 3.4 in the denominator, which means I multiply both sides by 3.4, which means the 3.4 is going to be in the numerator on the right side. So I end up with sine x equal to 3.4 sine 75 divided by 5.6. I have sine x, and so to find x, to isolate x on its own, I have to do the inverse sine. And so what that could end up looking like is sine inverse 3.4 times sine 75, all divided by 5.6. And so this is what I could enter into my calculator in order to figure out what x is. Alternatively, you could have figured out what the 3.4 sine 5.6, you could have done that on its own and then done the inverse sine of that. Totally fine, but I'm just going to do it this way, and I end up getting a value of 35.9, or I'm going to round to the nearest degrees, so 36 degrees. Pause the video, try the question on the right, and see how you do. The answer is 62.1, or rounding to the nearest degree is 62 degrees. So that's how we use sine law to solve for missing side lengths for angles. And the key characteristic of using the sine law is when you have angle and opposite side pairs, when you have two pairs of that with one unknown, that's an indication that you're going to need to use sine law to solve that.